What I have here is I want to show you a little bit of some proof of concepts and then an alpha prototype that I've created just to kind of show you some things that you can do and what I expect when I say I want a proof of concept. So quick review, a proof of concept is just a portion of your prototype showing that one part of it works before the entire thing works. If I can get all my proof of concepts to work by themselves, that means it's time to try to compile them into my final product. It doesn't mean that this alpha prototype is ready to be manufactured or that it needs to even work perfectly. There are sometimes some bugs into this, and it's just showing this is my first step. What you'd do after this is you'd test some more things and you would make it a little bit better, and you'd make a beta prototype. That beta prototype would still probably have some bugs, but you'd test it a little bit more. It would look closer to a finished product, and you'd keep testing it and upgrading it and getting the bugs out of it, and then eventually you could send it off to be manufactured. We're just dealing with the very basic parts here. So what we're doing is I have a button-activated tripwire alarm. I don't know if that name's necessarily that great. I'm going to show you the alpha prototype first so that you know what we're talking about throughout. So I go into the alpha prototype, I have some images here, and here's my finished circuit. It's sideways here, that's the way Google Drive's opening it for me. But what I have is I basically have three things here, and you saw on a previous screen that I had three proof of concepts. On this side, I know it's going to be hard to see here, I'll open up another picture in a second. I have my tripwire, the thing that's going to say whether my alarm's been triggered or not. This right here, the button and the LED tell me whether my alarm is active, and I have the buzzer here which is going to sound an alarm. So let's look real quickly at one part of this. We will go to the part that is going to activate the alarm. So here's my picture. I have a button and I have an LED, and you'll notice that I have lots of pictures. It's great to have pictures. It shows me that you have a circuit. Try to make them as clear as possible. You see the last one was kind of blurry, it was kind of far out, didn't show very much. I'm zooming in here, and it's good to have both versions because this one I can't see what's going on over here, I can't see what's going on over here, but if I look at all these zoomed in pictures, I kind of know how they go together because I have this zoomed out picture as well that I can look at things. But right now we're only concerned with this part of my circuit. This is just going to activate my alarm. I press the button, my alarm's activated, and I'll get a little indicator light here with my red LED. I have a better looking circuit, something that shows exactly how it's set up, and I even put some information down here on how it's set up so that I can go back later, figure out what's going on, make sure that I can replicate it or somebody else can see what's happening. I then have my version history. I have 4 versions of code here, and this code is going to all do the same thing, but I started off with a simple code. So the goal of my overall thing is to make a button that will alternate saving a 0 or 1 when pressed. So what this does is it allows when I press my, you might be able to hear that, you can't see it right now. When I press my button, the LED turns on and it stays activated. It stays on. I don't have to hold it down to do that. And then at some other time I can press the button again. Just one press, I press and release, and it turns off. That's my ultimate goal. So my first version I'm calling 1.0, all I did was I made sure that I could get a button to turn on when it's pressed, and when I let go of it, it turns off. We've done that multiple times in class. That's just our basic get a button to do something. What I did with version 1.1 was I got the button to, when I press it, it stays on, the LED stays on, even after I release it, and it won't turn off until I press and release again. It was a little bit finicky there. It wasn't working perfect, but I kept this anyways. because that was a good step. It showed that I did something even though it wasn't giving me perfect numbers. So what I did was I made a version 1.2. I copied version 1.1 into a new sketch, and I made some changes into there. And I didn't actually make too many. The main thing that I did was I added a short delay, and that short delay just let the values be more consistent. Then lastly, because this was working really, really well, I wanted to use this code, but it really wouldn't work if I wanted to compile things yet. Because if I have, let me see if I can pull it up real quick. There we go. So I'm opening up my sketch here. And you'll see that this has a void setup and it has a void loop. But if I want to compile multiple sketches together and they each have a void setup and they each have a void loop, the program won't run. I can't have more than one setup and I can't have more than one loop. So all my version 1.2.1 is I made my setup its own function. I called it button LED setup. And then I made my loop its own function. I called it button LED. So all this is the same stuff that was in my previous loop. All of this is what was in my previous setup. All I need to do is I need to call my button LED setup into my setup and my button LED into my loop, and it will run pretty much identically. There were a few things that I changed. Here I gave button LED an input, and I'm saving the value that comes out of it. All that's telling me is what state is it in currently? Is it currently in the on or is it currently in the off? And then I put some prints in here so that when I run it I can see what's happening. Let's go back to this here. So I have the picture, I have a circuit with an explanation, I have some version history, and my codes necessarily aren't there. If I wanted to, I could maybe embed a link to the codes into there just so it's a little bit easier. But I do have all my version 1 codes in this folder. And so I could download each of these codes, and I want to keep them all here. Even though I'm mainly only going to be using this last code, all these other ones are good steps, and if for some reason I need to use one of the codes later, maybe a version 1 or a version 1.1, I already have it saved, and I can go back to it and reference it, and I can maybe start adapting that one into a new code as well. And I do this for each one of them. So I have the alarm that goes off. You'll see that I have a picture. I haven't renamed this picture yet. It'd be nice probably to rename it something other than the time I took the picture. I have my circuit, I have my versions, and I have my version codes. This one I didn't have quite as many. It was a little bit more simple of some code. Again, this version 1.1.1 is the one that has usable functions so that I can compile everything together in the end. Real quickly, here's my tripwire. The tripwire is, I have a photoresistor and I have an LED. This LED is going to be on constantly. And so it's reading this really high light because it has an LED pointed right at it. And if I block it, it sees that something's blocked, and it will send a signal. If my alarm is also on, then my alarm goes off. I have, again, my version history. I have the circuit, an explanation of the circuit as well, so that I can always go back and reset it up, or if I want to modify it slightly, I know why each component's in there. Here I had a lot more versions. Version 1, I had 4 different codes, and it only got me so far, and it wasn't really working the way that I wanted, and so I did kind of a complete rebuild. Started over my code directly. That's why it's a version 2. It's not like I took the previous code and kept moving on. I just started over completely. I had 5 more codes in here, and finally I was satisfied with version 2.3.1, and again, the 2.3.1 is the same thing as version 2.3, except for I turned everything into a function so that I can use it later. Alright, I know I'm going through a lot of stuff here. I just want to show you that these, even something that is somewhat simple, you can still put a lot of information in here. Right now what I'm doing is I'm proving to you guys that I've done a lot of stuff. And I want you guys to do the same thing to me. When you come up with the project, I want you to prove to me that you've done a lot of stuff. You've done some testing. You've tried multiple things. If you needed to recreate it, you have pictures, you have diagrams, you have videos. And so here's my final prototype. I have my circuit, right? I have my tripwire, I have my button and my LED saying whether it's on or off, and I have my alarm. I have my circuit is explained here. I have my pictures, I already showed you those. I have my code. I only had one code here. I could probably start adding a few more. This code isn't necessarily perfect, but it does the job. So here's my demo video, and again, Google Drive is going to open it up sideways. Here's a video demonstrating my alarm system. So this is me narrating. We have a button here, and what the button does is it activates or deactivates the alarm. So this would be that the alarm is active. The alarm is not active. There's our buzzer so that the alarm sounds, and this is our tripwire. We have an LED and we have a photoresistor, and if something blocks the light between there, then if the alarm's activated, the alarm will go off. I'm going to use this piece of paper here, and you'll see that if I move this through here, I'm blocking the light, but the alarm's not going off. That's because we're not activated here. So we activate the alarm, it's now active, and now if I move this over, we have our alarm going off. Alright, so I don't know if you heard that. It was narrating through the computer. So I could add another version if I wanted to. I could add a way to turn the alarm off. I haven't done that yet. I could also maybe have additional LEDs flash or something when the alarm goes off as well. So I could add more things to it. This here is the code. So it is actually pretty busy. I'm not going to go throughout the entire thing, but I do want to show you just a couple things. I have my global variables, just like always. But you'll see in my void setup, I only have 3 things being called. I do have a print going, but I have 3 things being called, and these are my 3 proof of concepts, the setup portion of them being called. And so if you come down here, all I did was I copied and pasted version 1.2.1 into the bottom of a new sketch, and you'll see that I just have my functions here. However long this one ends up being. So right there. I did the same thing with the blinking LED thing, reading a blinking LED, my version 2.3.1, and I did the same thing for my alarm, version 1.1.1. So I'm going to just go over this really quickly. The setup's run, gets everything working. This line of code right here is just turning my alarm on if I press it once, and it turns it off if I press it again. It turns it on if I press it another time. This is just activating and deactivating my alarm. If my alarm is on, if it's active, then it's going to check the beam. It's going to check to see if my tripwire has been activated. If my tripwire has been activated, we go into here, and this is an infinite while. It runs forever. There's no way out, and what it's going to do is forever an alarm just goes off. So again, there are definite things that I can do to this to make it work better, but you'll see that my loop, all I'm doing is I'm calling my 3 functions, and I just am putting a little bit of logic in there so that I can navigate through the functions when I want to do certain things. How many lines of code is this total? It's 148 lines of code, some chunks of comments and stuff taking it up, but my actual loop, the part that's doing things, is actually relatively small. It's only maybe 6 actual lines of code. So that's it. There's a good few more things for you guys in your guys' folder. I want more than one video. You're going to start putting in some documentation. You're going to do a design proposal. You're going to start writing up why you chose what you did. It's great that it's all here, but it's kind of chaotic. It would be nice to have it all in one spot. And so what you'll do is you'll make a document. And the document's basically going to be a place where you compile everything that's in here, and you put it in a narrative form. And you'll start with, what's the project? And then you'll talk a little bit about some research that you did. You're going to look at what's already out there, maybe on the market, and you're going to say, and we had to figure out what components would work good, so we had to research some components. And then you're going to talk about why you chose the method that you did, and some things that happened during testing, and then you're going to talk about what happened while you were assembling it together, and you're going to talk about the timeline, and you're going to talk about what you might do to fix this or to make it better in the future. So this is a design class. We talk a lot about programming and a lot about circuits, but it's about making sure that whatever we're doing, whether it's using programs, software, whether it's using hardware, circuits, no matter what it is, we want it to all work well together and work the appropriate way, and to make sure that it's explained well, because you can do the best thing, you can create the best thing, but if you can't explain it to somebody, then nobody else can help you, and nobody else can manufacture it, and nobody can sell it, and nobody can do those things. And the whole point of engineering is to make sure that things are useful and that other people can know what you're doing and what's been done.